Hello and welcome once again to another episode of What's New in SimCenter Star CCM Plus from Engineer to Engineer. My name is Rodolfo Piccioli, and together with me today in the London Hammersmith studios is Annabella Grozzescu from the product management team. Hello Annabella, how are you today?
Hi, very good, thank you. Hi everyone.
So Annabella, you are product manager for SimCenter Star CCM Plus, automation and user experience.
Yes, that's right.
All right. And you are today here on the stage of the London Hammersmith studio to talk about stages. Is it correct?
That's a bit of a spoiler alert, Rodolfo, but yes, I'm here to talk about stages, but also some other interesting features we have.
Okay, excellent. And I start with a question that I always ask. How many new features we have in SimCenter Star CCM Plus 2310?
I counted them this morning and I think we are a bit above 130 new features.
All right, so 130 new features, enhancements, and so on.
Yep.
Excellent. Which one do you want to talk about first then?
Well, I want to talk first about a big change we're making, and this is the introduction of the automation node in the tree. And that's because it's something that I think will affect all of our users. Everybody will need to use it. So in this version, we are introducing a new automation node that, well, we are hoping that it improves your productivity because you'll be able to have more streamlined workflows. Before talking a bit more about it, maybe we can look at the slide to see what's in this new automation node. So you can see we have parameters, field functions, and all the automation enablers grouped together. Now, a bit of a funny story, when we released this internally, I was in the London office, and I could hear in the back someone saying, "Where's the field function folder? Where did it go?" And then after a while, that person came to me and said, this is so much better. But initially, it was a big hit.
Yeah, actually the same happened to me. It was not with field functions, but it was with time scales, I believe. And I had not a panic attack, but a little bit of concern because I couldn't find a lot of elements. So before that, whenever we didn't know where to put a new enhancement, it was going in the tools node. Now we have another one which groups actually all the automation related elements.
And not only that, I think it's also a field function that people use outside automation, but it goes there because that's... So how did you find it? Did you find the node? It's better for other people to talk about it.
Absolutely, I love it. I mean, it makes so much sense to have all these elements grouped in a new node. And avoids a lot of scrolling that previously was necessary, and now it is not there anymore.
Yeah, so I guess apart from the automation, you can also it's quicker to find parameters and field functions that everyone uses kind of every day, I would say, right?
Yes.
Okay, the automation node already anticipates what I want to talk about next, and this is stages.
Which is the one that I spoiled earlier.
Exactly. Yes. So from SimCenter Star CCM Plus version 2310, we are extending the automation capabilities by introducing the concept of stages. With stages, you will be able to have multiple physics set up in a single simulation and unlocking more and more automated end-to-end workflows and reducing further the need to have Java macros. You'll be able to stage different objects in the trees, and by doing so, you will be able to have different values for these objects in the different stages. A few examples of things you can stage now is physics models, physics conditions, but also other settings.
Yeah, can you make a practical example, because it might be a bit cryptic to all the people listening at home so far?
Yeah, I actually thought so. So one of the most common things people would do with stages is to run steady to unsteady simulations. So, and a good use case example for this is the thermal SOC for vehicle thermal management.
Yeah.
Of course, even before 2310, you are able to do steady to unsteady, but you would have to either manually change setup or do a Java macro. We also have other ways to do it, but those are the most common things, right? Now with stages, you'll be able to do that in an automated fashion. And with stages, of course, we introduce also kind of a workflow for stages that is quite easy to use. And if we can look at the video I prepared for today, I think this will shed more light on what stages can do, but also how you can make use of them. So in this video, we are creating 2 stages, one for steady and one for unsteady state, but you can create as many stages as you want. As soon as you create the first stage, a tree is going to pop up on the right-hand side, and in this tree, you will be seeing all the objects that you've staged. So it's quite easy to see what happened until then. You'll also have a toolbar at the top right of the simulation window. Now we're creating 2 stages, one for steady and one for unsteady, and we are staging the models. You just press the little flag close to the models, and we are doing steady, and then to unsteady. So we are now in the unsteady stage, and we are setting up the unsteady stage. With this, of course, you'll be able to also set up the solvers for the unsteady stage. So we are changing the time step in this case.
Am I right that all the elements with the flag can be staged?
Yes, you are correct.
Okay.
All the yes. Then as I told you, we have this tree where you can easily see the differences between the different stages. So you'll use the tree and change in the toolbar the different stages, and you see that in one stage we have steady, and in the other stage we have implicit unsteady. Now, I told you that we can stage different things in the tree, and an example in this video is we stage the tangential velocity. So in steady, we'll have vector, and for the unsteady, we'll have a fixed. We can also stage the type of boundary conditions, and in this example, we do for the ground, we set, for the top, we set it from symmetry, we put it to pressure outlet. Then we can also stage the some things in the interfaces. So here we are staging the interface energy coupling options to be implicit in steady and explicit in unsteady. A tip for all the users is if you want to check your setup, use the stage tree to see there. And the stage tree, I don't know if you play with the custom tree, it works a bit like custom trees. You have 2 different views. In one view, you'll see everything that can be staged, everything that's staged in bold, and in the other view, you'll see that element in the tree.
I see, right.
And one very important thing about stages is that you can leverage its power combined with the simulation operations. So you'll be able to use all the simulation operation sequence that you want, and you'll need to activate the different stages when you want this to run in between your simulation operation sequence.
Right, and a question. So I saw that some of the nodes are grayed out when I saw it in the video. What does it mean?
It means for now the initial capabilities is a bit limited, but we are working to extend that even further.
Okay. I guess a lot of people at home may want to use stages, for example, to switch between runs and LES. Is this possible now?
For the time being, this is not possible, but this is something we'll work. It's in our plan to work next.
All right, excellent. Anything else you want to add about stages?
Stages are amazing. Just use them.
Yeah, I had a very, very brief look at that, and I can confirm it is a game changer for a lot of applications. So I join Annabella in saying you should try it. Okay, Annabella, thank you very much for talking about the stages today. Stay with us here in the London Hammersmith studios, but for the next enhancement of SimCenter StarSystem Plus 2310, we are connecting to a colleague in remote. Hello, Gaetan.
Hello, Rodolfo. Hello, Annabella. Hope you're doing well.
We are doing very well, thanks. And so today you are going to talk about Cell Designer.
Yes, today I'll be talking about 3D cell design indeed. We are releasing in this 2310 SimCenter Star Sampler a new capability to address the design of lithium-ion cells in full 3D. And so this is one of our top major feature. So this upcoming solution allows you, as I said, to design lithium-ion battery cells in 3D, which means geometrically resolved electrode layers, separators, and tabs. So that is something that is making all the battery cells. And so this is quite often an unusual thing that we can see on the market at the moment. This capability is driven by simulation templates that we've built on top of that. Obviously, it comes with a 3D solution of the electrochemical behavior of the cell, and this is thanks to an enhanced model that we've integrated in the solution that is actually taking the formation of Newman-Dog-Fuller, which is the initial formation for the electrochemical behavior of the cells, and we've added that to SimCenter Star Samplers too. Also, as I was saying, this is driven by a template. So we've built a workflow which really helps the user to go through this very easily. It's customized and tailored for obviously cell designers, and it uses industry standards, terminology and units in order to make things much easier for them to follow that process as well. We've simplified things like, for instance, the setup for the meshing, for the geometries, as I was talking about. There's a few parameters to put in place. There's an easy workflow to update geometry, to update the mesh, to follow all the setups with the physics and so on. So this is, quite something that should be very easy to get familiar with. Also, we've also built a post-processing. So we've facilitated that with a lot of, industry standards post-processing, but also some customized post-processing that we thought would be useful for the user to reuse, so they can really focus on reviewing the analysis rather than trying to set up all of these plots and scenes that we've already packaged for them. So with this, the user can access detailed insight of the cell performance. For instance, you can look at in plane or through the thickness concentration, for instance, or many other quantities we have available. So this is kind of the unique thing about this is with all the competitive tools, you can look at so most of them are 1D simulation tools, but for instance, some of them could be 2D representation of the cells. Now, what we offer with 3D representations is that you can look into the in-plane distribution of quantities, but also what happens through the thickness of the electrode, and this is quite unique there. So I mentioned concentration, but it can be many other quantities, potential current density, etc. So that you can really study, for instance, what happens locally to the cell when it's actually undergoing a GT cycle. Is there are effects related to things happening to the tabs or things happening in the center of the cell? You can look at this. You can also look at what happens with edge effects. So this is related to the parts of the cells containing electrodes which are not participating with the exchange, but could create some effects that affect the performance of the cell itself. So this is about really in a nutshell, the capability of the 3D cell design. The capability, as I was saying earlier, is driven by simulation templates. Actually, there should be 3 simulation templates, one for each of the industry standard shapes. So a stack, cylindrical, and prismatic one. But for this 2310 release, we will only release the template for the stack one. In the end, the simulation can be accessible. Actually, the capabilities of the simulation, particularly also some of the physics models, are only accessible through the access of a specific license, which is the batteries add-on license. So within the license file, it's the battery sim license file. And so this enables the specific physics, which are the concentrated electrolyte model and the subgrid particle model, in order to fully run those type of simulation. So in the end, together with SimCenter Battery Design Studio, which is still our solution that we sell for early cell design simulations, this offering that we are releasing is really complementing this with a high fidelity solution and provides a full comprehensive approach for addressing set design with SimCenter tools.
Okay, thanks, Gaetan. Can you give me a concrete example? So once I have such a 3D resolved geometry of the cell, what can I do with that?
So what's a concrete example for in using the 3D cell solutions, and what's all unique about having this in 3D? So you can actually use the 3D cell design solutions to, for instance, study the impact of the tab or surface cooling. Now that we resolve all the electrodes, all the layers within the cell, we also then resolving all the current collectors sticking out of the cell. And so we can really see the impact of having the cooling performed on the tab. So the heat is dissipated from the cell through the current collectors and then into the tabs where you can place your cooling system there. Or you can compare this to a situation where you have the cooling on the surface of the planes, or the cell, so excuse me. So basically on the top and on the bottom of the cell, on the two sides of the electrode of the cell, you can place your cooling there and study the impact. So the advantage with the surface cooling is obviously it has much bigger surface, but really would start to cool the battery cell from the top and the bottom face, and then getting into the cell slowly. In that sense, there is the tab cooling. You can actually access the inside of the cell by obviously having those collectors getting inside the stack, and basically provide a much more efficient cooling, knowing that the current collectors are usually made of copper and aluminum, which conduct the heat quite well. So conduct temperature quite well. Excuse me. So that is one of the things you can do, but you can do many other things, and I mentioned as well edge effects and local effects you can look at.
Thank you very much, Gaetan, for being here at the What's New in SimCenter StarCM Plus. I really loved your explanation, your introduction to Cell Designer, and I hope to have you here soon.
All right. Thank you very much for your time, and have a great day. Thank you, Rodolfo. Thank you, Nebela. Bye-bye.
Okay, we are back to the London Hammersmith studios. Annabelle is still here with me, but she is not going to talk about the next few enhancements, since we are connecting with Andrea. Hello Andrea, how are you today? I'm sorry, but we can't speak Italian today.
Hello Rodolfo, I'm very good, thanks. You're right, but maybe we could say buongiorno.
Absolutely, buongiorno anche a te. So what are you going to talk about today?
Yeah, I'm very excited to be on your show today, because I'm about to talk about two major features that are coming out now in SimCenter StarCM Plus 2310. And the first one I wanted to talk about is actually a major development that has been in the works for quite some time, and I'm glad that we finally are releasing it. And this is a new series of models to study cabin comfort. So I prepared a number of slides. We can have a look to explain better the problem. So we know very well that cabin design, especially today with electric vehicles, is becoming ever more complex. You have external factors affecting the cabin, such as the solar loads, the presence of numerous heating components, such as heated seats or steering wheel. Obviously, there's the problem of the vent design, and recently we see also the adoption of radiative heat panels to help the cooling, or the in this case the heating of the cabin, but in general to reach comfort as fast as possible, because every kilowatt hour matters that you squeeze from the batteries to heat up the cabin. All these phenomena are available, can be simulated today in SimCenter StarCM Plus, but there's been an element missing, which is how to couple the human comfort. And with today's feature that I'm going to present, we are actually bridging this gap and allowing, with SteamCenter SaaS Plus 2310, we allow our customers to consider also human comfort within this already complex and multi-physics simulations, which is cabin design. We are doing so with 3 different models. I'm briefly going to explain all 3 of them. So the first one I would like to talk about is the so-called Fiala thermoregulation model. We see a schematic here on the slide. This is essentially a complete new solver that is acting on the mannequin level. So let's say you import your geometry of your mannequin, as we see here in the slide. And once you have segmented said mannequin in a number of body segments, such as the leg, the foot, or the head and the face, every one of these segments will be solved in the background, and a number of bioheat equations are computed in order to account what is the effect of the so-called active systems, meaning the radiation from the outside or the air temperature affecting the human body, but also the passive system, meaning the metabolic response that would be different for every person depending on the age or the height or the activity level, and the breathing, the sweating, and many more. So it is really a complex model that enables a new level of fidelity when it comes to predicting the response of the human body from all these phenomena that we are showing here on the slide, and eventually leads to the computation of a very accurate skin temperature. I also wanted to mention that we developed this model according to the latest improvements or latest literature, and that is why we call it Fiala, because it's named according to the main author, which is a professor in Germany at TU Darmstadt. So once we have computed the so-called thermoregulation part of comfort, we can move on and not only look at skin temperatures, as I was showing before in the slide, but also we can really quantify comfort thanks to a number of industry standards comfort indices. And for this, we move on to the remaining 3 models, which are the DTS, the PPD, and the EHT. So DTS, first of all, stands, as it says here on the slide, as dynamic thermal sensation, and PPD is predicted percentage dissatisfied. They are essentially 2 global indices, meaning you get one number for the entire body that will tell you, on one hand, on a scale from -3 to 3, how comfortable a person might feel in the given cabin. So the closer to 0, the better. It means that this person feels comfortable. And the PPD is a statistical indices, meaning comfort is different if you ask me or if I ask you. So there is a very strong element of statistics here, and the PPD captures that in the sense that this number here, for example, if you look at the yellow symbol, says that most people, basically 80% of the people, will feel cold in these conditions. That's why these 2 indices, they go together. Last but not least, if a global index is not enough for your studies and you really want to go in detail and optimize the topology of your cabin, or maybe look at how the vents are blowing on the different parts of the passengers, you can have a look at the EHT diagrams, where EHT stands for equivalent homogeneous temperatures. Here you get so-called local indices, meaning that each and every of the 17 numbers that are shown in this graph on the solid dashed line represent essentially how the driver or the different parts of the driver will feel in the cabin that has been simulated in this case. And thanks to this diagram, you can really not only assess comfort in globally for the passenger, but really fine-tune the design of your cabin or maybe of your heating components, the energy that needs to be spent in each of them, and optimize throughout the body how the person can feel as comfortable as possible. So to give you also an example of what you can do today, I have a short animation here where I'm showing essentially a sweep in temperature of the HVAC system. You can see it in the top right side of this animated scene. This is a summer scenario where we assume 38 degrees Celsius of outside temperature, and we're essentially trying to cool down the cabin. And as you can see, we found the best compromise between energy expenditure and human comfort with an HVAC temperature of 22 degrees. We've done so by looking at the comfort indices, which are shown here on the screen, but also looking at the comfort diagram, where we can see throughout the body how the person feels. And we see, of course, that there is some room for improvement if we look at how cold this person is feeling on the feet. But still, the important thing is that today customers can look at the cabin as a whole, including human comfort studies in one tool, in a fully automated workflow, and with the great benefit of all the automation that SimCenter SaaS CCM Plus has inbuilt, and we are constantly improving from release to releases. So I'm very excited about this feature, and also to know more from customers when they adopt it, how they feel and if they feel comfortable about it.
Right. Thank you very much, Andrea. It was really a crystal clear explanation. I haven't interrupted at all because I loved to hear that your explanation of the enhancement. It is really a major enhancement in SimCenter SaaS CCM Plus. And by the way, I never say it, but please, you listening from home or from your office, feel free to leave a comment about the enhancements if you like them, and suggestions and so on. And there is something else you want to talk about today.
Yep, indeed. So we talked about comfort and we focused on the thermal side, but we know very well that again, EVs, they introduce new challenges. And as we discussed in past episodes of this series, the other major challenge that customers have today is with acoustics. And it is a very important problem for electric vehicles cabins, but also in many other scenarios and many other conditions. So the second features I'm going to talk about is called conservative maximum distance mapping. So this, first of all, has to do with the vibroacoustic workflow, which has been a very successful story. We have worked together with the colleagues at SimCenter 3D. And essentially, the workflow consists in running first an air acoustic simulation in SimCenter SaaS CCM Plus, which is usually running on a very fine mesh. So to cite some number, we can be in the order of a handful of millions of even more number of cells. Then there is a step where the data are mapped from SimCenter SaaS CCM Plus to SimCenter 3D to calculate the forces, and this is usually done on a much coarser mesh. So in the previous workflow, we used to export via a CGNS file the detailed fine mesh solution from SaaS CCM Plus to SimCenter 3D. And in some cases, this resulted in, on one hand, very large files, so relatively long times to save the file, export it, move it, and read it into SimCenter 3D. But also there was a step in SimCenter 3D when we had to map the solution from the fine mesh to the coarse mesh. With the release of SimCenter SaaS CCM Plus 2310, and specifically thanks to the conservative maximum distance mapping, we have actually ported the exact same code that is used in SimCenter 3D today to map the fine mesh solution to the coarse mesh in SimCenter 3D and ported it to SimCenter SAS CM+. So in the new workflow, customers will be capable of taking the fine mesh solution, reduce it to the coarse mesh in SimCenter SAS CCM+, and then export a CGNS file which will be orders of magnitude smaller. According to our tests, we have actually reported speedups between 45% up to 90%. So this is, as we think, a major step forward in, first of all, the ease of use of the workflow, where you have a very compact and efficient file to move around, but also a major speed up in the old simulation toolchain from SimCenter SAS CM+ to SimCenter 3D. So very exciting.
Thanks, Andrea. Here I have a question. So anytime we talk about different workflows or very high speed up and so on, someone may be concerned whether results are consistent or not with the previous version. Do you have something to say about this?
Yeah, indeed. So I totally share this feeling with you, Rodolfo. So when every time I did any engineering work, I've always been in the position to upgrade to a new tool because I was afraid of all my validation work, and I was hesitant to look at the new results and maybe find some differences. But in this particular case, customers can be assured that the solution that you would get with the new workflow will be as close as it can be to the old one. The reason for that is because we have actually worked with the development team at SimCenter 3D and essentially ported the exact same code that used to be run in SimCenter 3D, and we've done it in SimCenter SAS CM+. So to further explain this point, I have on the slide a comparison where we can see essentially the two major quantities that are usually mapped from the fine mesh to the coarse mesh of SimCenter SAS CM+ to SimCenter 3D. And in our tests, we really saw one-to-one results. So customers should not expect any difference between the workflow results up to SimCenter SAS CM+ 2306 and the new one with 2310. It's just you're going to have straight out of the box a major speed up and a much smaller file to work with. So there is only to gain with this new feature for vibroacoustics workflows.
Absolutely, I can't really distinguish the two lines in the plot. They're absolutely overlapping. Well, Andrea, thank you very much. You presented really some major enhancements to SimCenter SAS CM+ today. It was a great pleasure to have you here at What's New in SimCenter SAS CM+ 2310. And really, I look forward to seeing you soon at another episode.
Yeah, same for me. It's been a great pleasure. Thank you very much, Rodolfo, and looking forward to the next shows. Wish you a good rest of the day.
Okay, thanks, Andrea. And now back to the studio with Annabella, who's going to talk about another new enhancement.
Yes, next I'm going to tell you about the possibility to connect Design Manager to SimCenter Reduce Order Modeling. This will allow to generate a reduce order modeling from existing simulation results and providing instantaneous and validated responses to parameter changes. But I guess it's a bit better if we can talk about this feature while watching the video, and I can tell you a bit more about it and the benefits that it brings.
Please go ahead.
We start in the simulation, as we always do for Design Manager. And first, we set the reference simulation parameters. Okay, so now we move to Design Manager. We set up the study. This works with all of the studies that we have available. So, okay, we set this up. We run the design of experiments as you normally do. When this is finished, next step is you just press select on the study to open it in SimCenter Reduced Order Modeling. And everything happens automatically in the background for you. And now we are opening the SimCenter Reduced Order Modeling is opened. And whilst we are doing this, there is a package that's passed from Design Manager to Reduced Order Modeling, and you can see it already opened in the software. Here, what's going to happen is that next you're going to create training, specify which data set is for training, which is for training, what's for validation, and you're practically done. Then you can, within the software, you can look at the different parameter combinations included in the range of your parameters that you specified in Design Manager. So you can see here how you can change the values as you want. One other thing to mention is that all types of parameters are allowed, and SimCenter Reduced Order Modeling will generate the prediction using proper orthogonal decomposition. And we have a fidelity index that's included to measure how accurate you are. And it's always relevant to check the fidelity index on your validation pictures as they are refined in the software.
Okay. And that's it for this announcement.
Yeah, I guess, yeah.
Anything else about licensing and so on? Do you want to add?
For the Design Manager, you don't need anything particular because you're just giving an automated way to export. Of course, you will need a license for SimCenter Reduced Order Modeling.
Okay, so thanks Annabella then. And now we move to another colleague, Kostas, who's going to talk about some new enhancements on the Surface Wrapper. Hello Costa, how are you today?
Hello Rodolfo, I'm doing really well, thank you. How are you?
Yeah, very well. I'm very excited for the release of SimCenter StarSystem Plus 2310. And I'm sure that I will be even more after listening the new announcement you're going to present, which is a parallel surface wrapper.
I'm really happy today because in SimCenter StarSystem Plus 2310, we're making the first release of the parallel surface wrapper. What we're doing differently in this release is that the surface wrapper pipeline has been MPI parallelized. After a significant amount of testing that we have done, we have seen that we have up to 43% reduction in the entire surface wrapper wall time, which also includes the parts of the pipeline that have been parallelized, but also the parts that have not yet been parallelized. And we have seen, as I said, up to 43% reduction comparing legacy surface wrapper on the same number of cores with the new MPI one.
Okay, so we already gave a sneak peek, basically. This is the first instance of the parallel surface wrapper, but not everything has been parallelized, not all the parts of the code have been parallelized, but we are already seeing that the new one is almost twice as fast than the old one, 43% faster. And developers are still working on parallelizing more parts of the code, which means that in the future releases, this MPI surface wrapper will be even faster. There is one thing that we should point out, which is that the legacy surface wrapper is not disappearing, but it is staying in the code in 2310.
That's true, Rodolfo. Legacy surface wrapper will be available as an expert property that our customers can actually use it to toggle on or off. This it will be like an option in the user interface. So because the new algorithm can provide a different set of results, for example, when you're using gap closure seed points, when you have the same settings in terms of the number of gap closure seed points, in certain instances, localized results of the gap closure faces, they might be different. But what we have also improved, the placement of the gap closure faces, and in a way making gap closure to adhere better to the user input. And so these are the changes that can happen. And we, in our attempt to give time to our customers to familiarize themselves with the new algorithm. This is the reason why we have kept the legacy surface wrapper as an option to be chosen and used whenever necessary and if it is necessary.
Well, Costa, thank you very much. I think it is a really very, very exciting enhancement. It was great to have you here today at What's New in SimCenter SRCM Plus. And I really trust that I will have you again at the next episode to tell us more about new improvements.
Thank you for inviting me, Rodolfo, and you will have me here in the future to give you more updates for the remaining of the work that we have for further parallelizing the surface wrapper pipeline. Thank you so much.
Thank you very much, Kostas. Now, actually, I had a question for you, Rodolfo.
All right.
Last time I presented this, you asked me what's my favorite feature. I thought about it now.
I always ask that, actually. It was not only last time, but this time I forgot it, actually. You're right.
Now, I thought about me, what I prefer, so I struggle. We have so amazing new features. So I thought, why not ask you, what's your favorite feature? Even though I know you might be biased.
I'm actually biased because as a lot of the audience at home knows, multi-phase is probably near the center of my heart. So I'm biased from that point of view. And I would say that my favorite feature in this SimCenter SRCM Plus 2310 release is probably the implicit multi-step for EMP LSI.
I was kind of expecting it. So do you want to tell people about it or?
Actually, I was kind of expecting your question as well, so I'm prepared to talk about that. So in SimCenter SRCM Plus 2310, as I said, we are introducing implicit multi-step to EMP, and we are targeting LSI, so large-scale interface simulations. Some users, probably I guess you're already familiar with the implicit multi-step, which was previously added to WOF, MMP, and so forth. Well, actually, just to WOF and MMP. But in short, it leads to more efficient EMP LSI simulations by either reducing the simulation time for a given accuracy or increasing the accuracy for a given simulation time. So how does it work in short? Within the flow time step, we can decide to carry out n sub-steps of the volume fraction transport equation. And this allows to maintain at the same time level, or even reduce, the CFL number associated to the volume fraction transport equation, but at a fraction of the computational cost, because the computational cost of a sub-step is much smaller than the computational cost of a full flow time step. We have an example here in the picture that you're seeing now, and this shows an application from the nuclear industry. So we have cooling water introduced, leading to a current of displaced gas. We can see also in the plot, I hope it is online now, but we can see that the speed up when the number of substeps is increased, and also the flow field at the end of the simulation, which is greatly consistent with the independent basically on the number of substeps. So great feature. I'm sure you're going to love it, and as much as I love it. And please try it. So this was the feature, or one of my favorite features of SimCenter SRCM Plus 2310. And what we are seeing now is that while I was talking about implicit multi-step for EMP LSI, a laptop appeared here on the table.
I thought I could be a bit more smooth, but...
Yeah, right. So what is the reason of the laptop? The reason of the laptop, you are already aware of this, is the 3-minute challenge. So every release, we ask the product manager here in the studio to, I wouldn't say demonstrate, but to show as many features as possible in just under 3 minutes.
Yes.
Annabella, are you ready?
Yes. Do we have a countdown? You're going to...
The countdown will appear here on the screen. If you can just move it slightly toward the center so we can see it. Okay. And Annabella, please. 3, 2, 1, go.
Okay, so when you create a new file from a simulation template file, the simulation guide will open automatically. And here, if you press on the links you put in, they open in your regular browser. Automation node, tags, you can group tags now. Yep, these tags are now in the automation node. Stages, we talked about them. We are creating 2 stages here. And I'm going to stage the models. We are going from steady to implicit unsteady.
So one stage is steady and the other implicit unsteady.
Yep. And we now have this magic button for where you have physics values, the x, and it converts it into a parameter.
So this avoids a lot of scrolling because you create the parameter directly from where the parameter is used.
Yep. And wherever you get this window, the expression editor, you have 2 buttons. The new parameter, it can create new parameter, as we're doing here for the velocity. And it gives you all the options to do everything you want.
By the way, 1 minute and 15 seconds have passed.
Yeah, and you do everything in line where you need. Don't need to go to the automation node now.
Much less scrolling, definitely again.
Okay, so we have these multi-value monitors, and now the plots, you can select only the things you want to see. So not all at once. We also have these new buttons. You can drag them, yep, and reduce the size of the axis.
This is so helpful, really.
Yeah, and here you can also resize. Go back. Okay, let's open a scene. And create a resample volume. Now, when we do this,
1 minute left.
we have this preview button where you can see the resample volume mesh lines, so you can see how fine it is and everything. There's other things to it, but I'll let you discover them. Yep, in scenes we have a new type of display line integral convolution. Selecting the derived part here. Yep. This is comes with a lot of benefits, but it's also easy to set up the properties. No pressure, Rodolfo. Yeah, we have in summaries, you can create summaries as you do, and select what you want.
All right, the summary reports, yeah.
And you can open them in the actually in the UI without the need to export them. And if you want to add stuff to it,
5 seconds left.
you can reload and you see everything that happens in real time.
Stop!
Yes. And we're done.
So, I think we forgot to mention that the 13 was the record to beat, still owned by Liam. I think I counted the 12. I think this last launch SimCenter Cloud HPC, I think it was outside the max, the 3 minutes, but we will check. Anyway, 12 features in 3 minutes is a great achievement. So thanks, Annabella. I think
Thank you.
Very well done.
Thank you.
Okay, we are at the end of this episode. And as usual, I want to thank a few people. I always do this and I'm becoming used to it, but I can guarantee that these thanks really come from the deep of my heart. Let's start. I want to thank all the SimCenter Star System Plus developers and product managers who are basically the enablers of all the new features that we have seen today, either presented by the product managers or in the challenge, and many more that you haven't seen. But Annabella, I don't remember if we mentioned this. Did I ask you how many new features, new enhancements are in, I think...
We did at the beginning, I think it's around 130, yeah. Around
130, so thanks to all the developers and product managers for enabling them. And thank you, Annabella, and thanks to the other product managers who presented remotely. And Annabella, do you want to say something?
Oh, thank you for having me here. It was fun. Hopefully I'll win next time the challenge. I'll beat the record. And thank you everyone for your interest in what's new, and hope you can use them. Yep.
Absolutely. I hope you had as much fun as Annabella and I had here in the studio. And I hope that you love all the new announcements in SimCenter Star System Plus 2310. So thank you very much for attending, and see you soon at another episode of What's in SimCenter Star System Plus from engineer to engineer.